1, example 1 here. We've got a flywheel which accelerates uniformly from 120 RPM to 200 RPM in 5 seconds. So similar sort of problem. Calculate the angular acceleration of the flywheel and the angle turned through in radians. So list what you know. We know that omega 1 is 120 RPM. Now, that's not actually an angular velocity, is it? That's a frequency. So the problem here is that we're not given the angular velocity, we're given the frequency. So there is a direct relationship between angular velocity and frequency. And that is that omega, the formula that we've written down before, 2 pi f, isn't it? If you think about the rotation that we've been talked about, 1 complete turn is 2 pi radians. So if I multiply that by the number of turns per second, I've got the angular velocity. So omega equals 2 pi f. So the frequency is 120 RPM. So we need to multiply that by 2 pi, but also we need to do something else. So what's that? Yeah, put it into seconds. So in fact, omega 1 is going to equal 120 over 60, which is turning that into revolutions per second, and then multiplied by 2 pi, which gives us 2 times 2 pi, which is 4 pi. Often worth leaving it in terms of pi. So let's leave it in terms of pi at the moment. That's 4 pi radians per second. So similarly for omega 2, that's going to equal, the frequency is 200 RPM. So therefore omega 2 equals 200 over 60 times 2 pi, which is 20 over 3 pi radians per second. So now we can find alpha. Oh, we know t as well, don't we? It's 5 seconds. So now we can go ahead and find alpha. See if you can carry on and finish that problem now, and then we'll have a look. So I get alpha equal to 1.67 radians per second squared. You could leave it in terms of pi and work out what that is and leave it as 8 pi over 15, because that's an exact answer. As soon as you then work out what that is, you're now rounding that, aren't you? So once I've done that, of course, I need to put at the end the 3 significant figures or whatever accuracy you're after, but you are rounding as soon as you work out the final answer. So alpha turns out to be that. So to find theta, using the formula omega 1 plus omega 2 over 2 times the time, rather than using the alpha that we calculated, we could use that, but using this, we end up with an answer of 80/3 of pi, exact answer, or to 3 significant figures, about 83.7 radians.